you nothing that I say.
Master, moving stones around is one thing. This is totally different.
No, no different. Only different in your mind. You must unlearn what you have learned.
All right, I'll give it a try.
No, try not. Do. Or do not. There is no try.
We've been playing this game since before the birth of this planet, and will continue to do so long after the death of yours. We don't cause the destruction of a world, Captain Carter. We simply manage it. Feed off it, if you like. But on every host planet, it always plays out exactly the same way. Populations rise, societies divide, wars spread. And all the while, the neglected planet slowly fades.
They'll come at you sideways. It's how they think. It's how they move. Sidle up and smile. Hit you where you're weak.
How are you doing this, Vincent? How have you done any of this? You want to know how I did it? This is how I did it, Anton. I never saved anything for the swim back.
Remember, the enemy has only images and illusions, behind which he hides his true motives. Destroy the image, and you will break the enemy.
The best way to show that a stick is crooked is not to argue about it or to spend time denouncing it, but to lay a straight stick alongside it. Dwight L. Moody. Good evening, everybody. How is everyone doing? Alright, so this is going to be a part one. Not a part one as in there's going to be more parts to it. It's going to be 3 videos I'm planning to do tonight. I may not get to 3 videos. I may get to 2. So let's get on with it. Now, you're probably thinking, hey, why are you using an evangelist's quote? Well, I like the quote. It's a good quote. Just because I'm agnostic or think of something a different way or think of certain people or religions or organizations, whatever. If something is good and I like it and it's worth using, I think it's good. It's worth using. So, good quote. So, a lot of people who believe in the globe Earth model, they tout as the main proof that the Earth is a globe is that there are curved shadows that are cast onto the moon, and that it's from the sun, and that because those curved shadows are in the shape of a sphere, that it is proof that it is a round ball that is causing that cast shadow. Well, if you watched any of my earlier videos, you'll know that that's not true. And it doesn't really matter whether I state that for example, if I state that the Earth's shadow that's cast on the moon is proof that the Earth is flat, is a flat sphere, I would say no, that's false. Because being able to have two possibilities, at least two possibilities, there could be more. And just wait till I get to those ones. I may not get that over today, but if I'm to show you that there's two possibilities and not just one, that means it's not proof. Now, proof is beyond, is just think of it as, sorry, I was going to play this video, as, you know, you heard the saying, presumption of innocence is the legal principle that one is considered innocent until proven guilty. The prosecution must, in most cases, prove that the accused is guilty beyond reasonable doubt. So we can go ahead and apply that to proof, as far as scientific proof, even though many people will say, well, scientific evidence, it's impossible. But look, I just want to go by with what normal everyday people and what they'll use to look up something, which is current days. It's Google. And then what are they going to click on? Most likely they're going to actually click on Wikipedia. They're going to look on what the top ones are. And you could look at Forbes if you want to look at mainstream corporate media. They say scientific proof is a myth. And then there's also one with climate.nasa.gov. How do we know? Evidence, facts, climate change. And most people will go with NASA because they don't want to look at some potentially conspiracy theorist slash flat earth journal article, whatever. They want something that will present and better present their outtake on what they've been told is. Now, this one is evidence. So what is evidence? And they don't really say, do they? They just, I guess they don't give a definition. That would be awesome if they did give a definition. But aside from that, all we have to do is listen to NASA's Michelle Thaler, which you will see, because one of the proofs that they use is that, well, what is going on? Did I close it? Sorry, having some issues here. Sorry. Pythagoras in Anaxagoras 500 BC, Earth is a globe because of curved shadow casts onto the moon from the Earth. Also from solar and lunar eclipses. Okay, and you're going to hear that from Michelle Thaler, who is, let's see. They give her credentials somewhere. Wow, did they just not give out who she is? I'm sorry, I'm kind of postponing. Oh, here we go. Actually, what I think I did was I just looked up. And actually, in the video, I think it tells you who she is. And, she's an American astronomer. She's the Assistant Director for Science Communication at NASA's Goddard Space Flight Center. From 1998 to 2009, she was staff scientist at the Infrared Processing and Analysis Center and later manager of the Education and Public Outreach Program for the Spitzer Space Telescope at the California Institute of Technology. She is also a frequent on-camera contributor to programming on the History Channel and Science Channel. So, let's listen to her for a second, or a few seconds.
Then there are some other proofs that are a little more obscure, but they're actually really lovely. And one is to observe what happens during a lunar eclipse. Now, a lunar eclipse happens when the Earth casts a shadow on the moon. The moon actually goes dark. In fact, if you've seen one, you can actually see the Earth's shadow go across the moon. And when the moon is entirely in the Earth's shadow, the moon looks kind of dark and even kind of red colored. It's really, really beautiful. What's happening in that case is that the sun is on one side of the Earth. The Earth is in the middle, and it's casting a shadow. The Earth is casting a shadow on the moon. And as the shadow moves across the moon, you'll notice that the shadow is curved, it's round. So something like the sun that's bigger than the Earth and is able to cast a shadow of the Earth on the moon can actually show you the shape of the Earth. Aha, you might say, but could the Earth be a disk? Could it be flat, but it's actually still shaped like a disk, not like a sphere? There was a Greek...
See how that was cut? She didn't answer. She didn't answer yes or no. Now, if we just do, like, I'll play it back. Here, let's do it again.
Could it be flat, but it's actually still shaped like a disk, not like a sphere? There was a...
She didn't say yes or no. She's going into a segue. But, I mean, it's pretty simple. And again, I wish I took Kathy's example, like pinning this up somewhere. But, alright, here we go. Ah, stupid. Alright, here we go. This is say this is the sun. I know I've got multiple light sources, but this is so bright. 1500 lumen light bulb. Okay. Now, I'm going to cast a shadow onto it. Okay. That shadow. Right. That shadow right there. Curved. Very circular onto this picture of the moon. I know that's not very good. Right. What is this? Bad example, but I've had already 3 videos already showing this, so that's that. So here we go. This is a flat disk. She refuses to answer because if she answered and she says yes, well, then it's not a proof. And of course, then everything that NASA wrote on as far as what is that it is a proof, it's high secant fine, high Vahid M. So if she said yes, that could it be a flat disk, then it pretty much would be not a proof. So again, here we go.
The Greek science flat, but it's actually still shaped like a disk, not like a sphere. There was a Greek
So she won't answer yes, so she's gonna have to go on with the story here. Now let's go.
Scientist called Aristarchus, and what he noticed was that you can get a lunar eclipse at many different angles where the sun is. Sometimes the shadow goes straight across the moon. Sometimes it just kind of glances the moon. Just a little bit is in shadow, just on the top or on the bottom. From every different vantage point, every different angle that the sun is casting a shadow, you always get a perfectly curved shadow. The only shape that can cast a shadow that's curved from any direction you put the light is a sphere. So people have known that the Earth is spherical for thousands of years.
The only problem with that, when she says Earth has been known to be a globe for thousands of years, it's actually just 2,000 years. Because if you're going back to 500 BC, maybe it's 2,500 years. Still, it's not quite thousands. Like she's saying, hundreds of thousands. Civilization before that has largely contributed that the Earth is flat. How long has human existence been? Hundreds of thousands of years. Civilization, even ancient civilizations, tens of thousands of years. Yet, because the last 2,000 years, it wasn't even a consensus. It probably was a consensus maybe around 1700s that Earth was thought of as a globe. But just because it's a consensus doesn't mean it's true. I mean, if the consensus was before that Earth was flat, well, then you're going to be with the consensus that Earth is flat. That doesn't necessarily make it true. Here, all I'm trying to point out that, well, curved shadows on the moon is a proof of the shape of the Earth. It's, again, she's going into additional ideas, additional assertions that, hey, Aristarchus, even though Aristarchus never left Alexandria to calculate the circumference of the Earth, one of the things that he assumed, and again, if you go back to another video, it's a video called Globe Earth Declarations, and it goes through everything that's written here. Everything that's written here is copy pasted from search results that were done on Google, and the top, I think at least 3 or top 3 or 5 search results, and I click on it, and then I grab the information from here. So when we look at Aristarchus, well, here I think she was talking about it. Actually, I was talking about Eratosthenes, who never left Alexandria, calculated the Earth's circumference without leaving Alexandria. If she was talking about Aristarchus, who says Earth rotates on its axis and revolves around the sun, well, the thing is, he didn't really note that it was a globe. He said he didn't mention it was flat either. So interesting. Now, the idea that the Earth, if the Earth is what's between the moon and the sun during a lunar eclipse, and so therefore the shadow that's cast onto the moon is from Earth, but that because that there's a curved shadow, and imagine this is just, see how there's just a curve, right? I'm not really doing a shadow, but placing it in front, it's going to cause a shadow behind it that's flat, two-dimensional, it has no volume, it has no depth. Well, it's a proof of the shape of the Earth when it could be one or the other. Well, you can't choose one or the other and say that's proof. There's 2 possibilities. And this was back in, again, 500 BC, where NASA apparently is claiming proof. The only problem is, well, the scientific method was introduced by many different scholars, philosophers, scientists, and they're figuring out, okay, we've got problems with just observations and measurements because there's still possibilities. There's many possibilities, and we got to limit the possibilities until we know exactly what it is. Otherwise, we're just left guessing. And, you know, it doesn't matter how many people go on one side and how many other people go on the other side, and they just go argue back and forth. We just need a definitive method in order to figure out what is causing something to happen. Now, if you look up who originated the scientific method on Google, you're going to get back Roger Bacon as the first one who invented the scientific method, explorable. The only problem is they only do a paragraph. The thing is, if you actually go into it, again, explorable.com, who invented the second scientific method, it's here. That's a good article to read. That's what the mainstream corporate historical notation is. Because that's what people will find. People will go, hey, who originated the scientific method? Boom, this is what people will find. They won't go into library to look at a book or something that was, they're going to look at the most recent interpretation. Because no one looks back and say, hey, who originated the scientific method? And if you look into a book that was made in like 1818, and it's like, oh, and it argued from that point, and you're gonna have people go, well, that's not the latest. I mean, there's many iterations. A lot of things happened since 1818. So get with the times, man. That's what people will say. So you have to go with what's out there. Because what we want is to people be on the same page. We want people looking at what is it that we're actually standing on, and not necessarily look to gatekeepers to tell us, and we just go, okay, I guess you're right. I mean, I'll never know. You claim it, and you're in charge of it, and you say you've got credentials, therefore we should believe you. I'm pretty sure most of you don't agree with that. I don't agree with that. So what's interesting is, here, they'll even say it, whilst the Greeks were the first Western civilization to adopt observation and measurement as part of learning about the world, there was not enough structure to call it the scientific method. It is fair to say that Aristotle was the founder of empirical science, but the development of a scientific process resembling the modern method was developed by Muslim scholars during the Golden Age of Islam. and refined by the Enlightenment scientist philosophers. So it talks about the Muslims and the scientific method between the 10th and 14th centuries. Okay, this is I don't know what happened to like 1500 years, 15 to 1900 years before. I mean, after all that, they're just going, oh, we're fine with observation and measurement. But it says here they were first to use experiment and observation as the basis of science, and many historians regard science as starting during this period. Amongst the array of great scholars, Al-Haytham is regarded as the architect of the scientific method. His scientific method involved the following stages. 1. Observation of the natural world. 2. Stating a definite problem. 3. Formulating a robust hypothesis. 4. Test the hypothesis through experimentation. 5. Assess and analyze the results. 6. Interpret the data and draw conclusions. 7. Publish the findings. These steps are very similar to the modern scientific method and became the basis of Western science during the Renaissance. Now it goes with Europe and the Renaissance. And Roger Bacon from 1214 to 1284 is credited as the first scholar to promote inductive reasoning as part of the scientific method. And he goes with observation, hypothesis, experiment, verification. And then it goes towards, I don't know why nothing else was really covered here, 300 years later, a person named Francis Bacon, I don't even know if they're related, Roger and Francis Bacon. But, and then of course, Rene Descartes in 1596 to 1650. So, Francis Bacon, what's interesting is they call it the Baconian method, which I never heard. That's like a, dang it, what's that term? A Mandela effect or something, because I don't recall Baconian method. But his was empirical observations, systematic experiments, analyzing experimental evidence, and inductive reasoning. Now, the other idea with Rene Descartes is he broke away from the model of induction and reasoning and again proposed that deduction was the only way to understand. Harking back to Plato, his method was almost the reverse of induction, which is to establish first principles, deductive reasoning, interpretation, and mathematical analysis. So now, interesting tidbits is here. Descartes believed that the entire universe was a perfect machine that, if you knew the first principles, derived from mathematical proofs. As an example, he deduced that planets revolved around the sun because they were floating in liquid at their ether, filling space. Ether. Ether or vacuum. Why does it always have to be one or the other, huh? So, the thing is, when you make an observation, you're gonna go ahead and say, hey, what is causing that observation phenomena, whatever it is, to occur? And then you may use logic, whatever it is. It's kind of easy. It's harder to manipulate celestial bodies, the sun, the moon, the stars, the earth itself. It's gonna be very difficult to manipulate any of those as variables. However, you kind of have to think about, well, shadows. Are the shadows that we're seeing on the moon the same as shadows that we see here on Earth? Whenever there's a light, there's shadows cast. Well, if there's a shadow and the shadow that's cast is a rectangle, is the shadow that's going to be cast, are you going to say that what's causing that rectangular shadow is a circle or a sphere or a ball? Most likely you're going to say no, because we just tried it. It doesn't look like what's cast on the moon. And then you look at, okay, well, we've got a round ball, and you put it before something, and you go, okay, hey, we could have the shadow that's cast onto the moon. It's probably caused by something that's a ball shape. But then you go, well, wait a second. Why does it have to be a ball? I mean, it could be a flat disk. It's like, hey, yeah, right. No matter what, if we do the same thing, it's gonna cast that same curve, that same round shape. So you're left with two possibilities. Could be more. Could be because the possibilities right now is that that's the shape of the Earth that's casting a shadow on the moon. What if it isn't? Now, a lot of people go, well, why are we know that it's round because, and this is what they're going to have to use, because the shape that's cast onto the moon, the cast shadow, the shape is a round ball. Because if it was a flat disk and the flat disk was spinning, well, it won't always cause a round shape, would it? And someone will have to go, yeah, I guess that reasoning's logical. But then you just go, well, who's to say that the Earth is spinning? I don't feel it spinning. I don't see it twirling. And someone goes, well, just look at the night sky. The stars are moving. And they go, yeah, the stars are moving. That doesn't mean we're moving. And they go, no. The stars aren't moving. We're moving, so it looks like the stars are moving. You go, well, it could be one or the other. And who's to say that what you state, what you assert, is the correct one? This is all through observation, remember. This is way before the scientific method was even produced by the Muslim scholars back in the 10th and 14th century. 10th through the 14th century, or they say 12th and 14th centuries. So there's just based on observation and logic, you can draw a lot of possibilities of what could be. And then one of the things that's used as an argument by globe earthers to declare that the Earth is a globe. The thing is, the current pseudoscience out there, they make these declarations that the Earth is a globe. The problem is that there are some on flat Earth, not all I would say, but there are a few that claim that no, it's a flat Earth. Now, they would have to use the same scientific principles or maybe observations as the globe Earth modelers. The only problem is they still haven't proved one way or the other. No side has proven anything, whether it's a globe Earth model or a flat Earth model. The take, however, from many flat earthers are that, well, how does what we see present itself? Okay, we see everything with the Earth that we're on presenting itself as flat. Water is level and flat. It doesn't ever form into some bulge. Whether it's the sun being directly overhead or the moon directly overhead, we don't see this bulge. We don't see any curvature. And people will go, well, there is curvature because I saw pictures and I was on a plane and I saw a curve. But then, well, you get people who are on leading edge of or representative of the globe Earth model, like Neil deGrasse Tyson, saying, no, if you're 120,000 feet up, or he uses the little model, 2 millimeters above the surface of this globe, you can't see curvature. And there you can go by that, or you can go by, I mean, if you're thinking about someone who's a representative of your model or pseudo-scientific community. So again, we have this problem between proving something which we cannot prove, and a lot of it is based on observations. Observations aren't going to prove anything. It can prove one way or another. Okay, and we've had this problem since the argument where globe Earth has exploded, the heliocentric model. And it's pretty interesting because one of the most modern proofs that Earth is a globe, the reasoning is that when you look into the horizon, you'll see ships or objects, helicopters going over the horizon, and they'll disappear the bottom part first and then above. Well, now we've got some higher grade cameras. A lot of people who make videos, content creators, they film with telescopes, binoculars. The Nikon P900 is very popular, Nikon P1000. And they'll observe it and say, hey, it doesn't happen all the time. I mean, certain times it's hard to see because you get refraction or just haziness. It's just weather conditions contribute to it, whatever it is. And then for me, it's like, what convinced me? I mean, there's so many variables, it seems, like even through observation. And for me, observation isn't proof. But you know what does convince me? And I'm going to show you my channel. Is that, well, the proof to me, and it isn't proof, it's more of a, what would you call it? It's more of integrity, okay? So someone is presenting that I'm doing research, I'm doing a scientific experiment, and the person whose show, the show's name that PBS had was called Genius by Stephen Hawking. Okay, Stephen Hawking is a very, very well-known physicist and mathematician. So you've got a show based on a well-known, highly regarded scientist, and well, that show that uses his name, they go out and they run an experiment. And I'm going, okay, this is it. This is proof. At least for me, that an observation, the scientific experiment that they have, that we'll see that curvature, and the curvature, which they don't mention, but it is mentioned by those who calculated out the curvature of the Earth, which is 8 inches per mile squared. I was thinking, okay, this is an observation. Let's see how it turns out. And the thing is, they film it. Of course, you can see that they're using a helicopter. Here we go. And he's got this huge, they have this huge telescope, and he's witnessing it. And here's what's being seen. All right, it's like, huh? Well, helicopter going down over the horizon, curvature. I'm like, all right, that seems convincing enough to me. The only problem is, well, later on,
as it lands, it completely disappears from my line of sight.
You're gonna see 3 birds again, and I hate reiterating this.
Let me know when you can see us on spot of the horizon.
I got him.
All right, so it's like, oh, all right, that looks convincing. And then I noticed, look, there's 3 little birds. I didn't actually notice it. Other people who are watching it noticed it too. They call it Discovery Channel. I guess Discovery Channel also aired this. But I watched this through Amazon, which they call it by PBS's Genius by Stephen Hawking. Well, I went back and I revisited it, and it's like, is that true? Is it? I mean, I have to look for myself because, well, people could just be editing the video. So I edited the video. And I edited the video just so you can see a better part to it. You can go do the research yourself. You can look at it. You can even see my other video on it where I actually show you the side-by-side. And the side-by-side has the actual URL of each of the same video, and you can find that here. It's the 13 minute 11 second and 14 minute 9 second mark. You've got 2 video snippets, one with the helicopter going down, with the helicopter going up, and 3 same birds that go across the water, same position, same angle, same formation. And it's, for me, it's if you have to fake it, if you have to fake your scientific results, it's nullified. It's not proof at all. So all the proofs that the globe Earth model is stating isn't holding up to scrutiny. And the ones who are trying to prove that it is, anyone that's trying to prove that it is, they're saying, hey, it's not holding up to scrutiny. What is going on here? And the thing is, people who are in the flat Earth side, we don't know if we don't have proof that the Earth is flat. But the thing is, we're not stating and saying scientifically, with scientific evidence or proof, that the Earth is flat. We're calling us flat earthers because the ones who are on the globe Earth model side, they're stating that there is proof that the Earth is globe. So what we're just looking into is like, well, there's just issues with the Earth as a globe model, because whenever we look into it and we do our own research, or we look at other people's research, well, we find inconsistencies. Like, you guys are editing the video, you guys are editing the results of your experiment. And so if you're lying about it, well, that just pretty much supports that there is no proof. And if you're able to edit this, who's to say that you haven't edited anything else? And if your final say on any of the matter is, well, we had gone to the moon, we had astronauts onto the moon, we've got astronauts on the ISS, the Space Center, we got pictures that we've messed with that shows the Earth, you know, that's a globe. But then when you look into that, you're going to just find more inconsistencies, and then you're going to note that, look, if you lie once, just once, of all the statements that anyone on a globe model side makes, that there's proof, or that NASA is a spokesperson for NASA communications, if they lie once, that's it. Game over. You've lied. You faked something once, and we caught you. Game over. It's done. We caught you. It doesn't matter what you say. It doesn't matter what you show anywhere else. We already know you lied. We already know you fake stuff. So we're not going to believe you. And that's pretty much the flat Earth side. There are, however, people on the flat Earth side that's making the same claim as the globe Earth side, stating Earth is flat and here's proof. There is no proof. There's no scientific experiment that you can prove that either way Earth is flat or a globe. You can make observations, you can make measurements, you're going to need assumptions made. And the biggest assumption made about the circumference and the radius of the Earth is they tell you straight up. For Eratosthenes, he made 5 important assumptions, none of which is perfectly accurate. So in order to measure the circumference of the Earth, you had to make the assumptions that the Earth is a perfect sphere. Does anyone understand that as a catch-22? And again, don't take my word for it. Why don't you do a Google search? And the Google search is going to be Eratosthenes, because you're going to look into Eratosthenes because he's the one who calculated the Earth's circumference. And you're going to go look into Wikipedia, which is going to be the second result. It was the second result on mine. And you're going to look at the measurement of Earth's circumference. And you know what? You're going to read here, like I copied and pasted. Eratosthenes, he made 5 important assumptions, none of which is perfectly accurate. Like, I did not lie. I copied and pasted that exactly here. He made 5 important assumptions, which is perfectly accurate. And all I'm telling you to do, if you want to do it, is make a Word document. Copy every question that you have that proves that Earth is a globe. Just copy it down. And look into it. And you're going to find out that it doesn't hold up to scrutiny. And again here, that the Earth is a perfect sphere. Number 4. Copied it down, that the Earth is a perfect sphere. So you're going to see, just like I had, you're going to go over everything and you're going to just question. It's like, all right, is it proof? Is it scientific method applied? No. It's based off of observations, based off of assumptions. More assumptions. More assumptions. Of course, then there's the scientific method, so you know where it started, where they say, hey, this is where it's kind of official with whatever it is. And you look at the math, the mathematical formulas, and you look at more assumptions, conclusions with no validity, and just on and on and on. And if all you have to do, you don't have to be the smartest guy in the room. You don't have to be the smartest guy, period. I say myself as the dumbest person in the room. But you know what? All I do is I don't lie to myself. I don't lie to others. And based off of that, you're going to find the truth. Okay. So, as a flat earther, for me, I'm not looking into flat earth as proving flat earth. No. I'm going to look into globe earth, just like I want you to do, and make it hold up to the scrutiny that they say proves flat earth. I mean, proves globe earth. Okay. So just go ahead and look into more how they debunk flat earth and just look into it, dig into it. Is it true? Is that proof? Is it an assumption? Can it be something else? Could it be flat earth? They go, no, it can't be flat earth because here's proof that it's a globe earth. Well, it doesn't. It looks like all your proofs aren't proofs. At the end of the day, your biggest reason is I've seen people who've seen people. I mean, I've seen people or know people who are astronauts, which is a club you can't get into. Heck, the last person, the last civilian that made it, that tried to go into outer space, Challenger, that exploded or supposedly exploded. It didn't go so well for that civilian. Do you wonder why? Do you wonder why that they made it so they exploded? Do you wonder that, hey, maybe they had to explode because they don't want anyone who's not an astronaut or with certain, they're not in certain clubs or secret memberships or whatever. They don't want civilians, any normal Joe to go up into outer space. Well, they can't, but two is if you could, and they're gonna look at the Earth and go, "Where's the globe? What happened?" And they go, "Well, look, the last time we had a civilian, it didn't go so well. So for people's protection, we're just gonna make sure that only astronauts who are willing to take that risk will go up into space." Okay, I think I got my point across. 43 minutes. It sucks that it went so far. Actually, you know what? I'm just going to go a little bit further because I kind of don't want to revisit this topic tonight. Not only going into that, but it's like, okay, look into ancient civilizations. And I'm going to go into this in another video soon. So this is kind of like a preview, kind of where I'm going at. They say, well, Earth was proved to be a globe from 500 BC by Greek philosophers and astronomers. Well, what about all the ancient civilizations? Talking about the Maya, the Egyptians, the ancient Chinese. They were all good at astronomy too. If you look up all of them, you're going to find great stuff. You're going to go, what Maya? What caused lunar eclipses? And then you're going to have 1, sciencing.com, 2, well, look, I have Maya, what caused lunar eclipses. This has nothing with Maya in it. So I went to the next one, which is Mayans accurately predicted solar eclipses, hundreds of years by Denver Post. So I go to the Denver Post right here. And what do they say? Well, Mayans accurately predicted solar eclipses hundreds of years into the future. So think of that. This is by Danica Worthington over at Denver Post on August 17, 2017. So you've got an ancient civilization, and the Mayans, not only did they so-called invent the 365-day yearly calendar, or actually, I wouldn't say invent, but had it, as well as the Egyptians, because I'm going to show you There's so much. Oh, I didn't make it into a Word document. That's why. Give me a second, folks. Calendar. I gotta fix all this stuff. Give me a few. Cold science. Is that what I'm doing? Yeah. Okay. The latest one is 10:15. Here we go. So I made this back in October 15th, 2018. So this is a long time ago since I even mentioned this. And it actually started when I started looking into it. I think. When did I start looking into it? July 21st, 2018, I guess. Around then. So I looked into this a while ago. So do you ever wonder how we have a full year that's 365.2425 days? You know, where did those extra 5 days come from? And you know what? You're going to see that going back to 3114 BC, the Mayans did. And then the Egyptian calendar, 365 days a year from 2773 BC. I mean, the Egyptians figured it out. It's like, well, like the Greeks in the 500 BC, they're thinking that Earth was a globe. And I guess up until, heck, Johannes Kepler in 1609 AD, I guess everyone at that point was saying, well, Earth is round and everything orbits everything 360 degrees, because a full circle is 360 degrees, and all the calculations is made based off of full circles. But then they go, well, if these orbits happen like a full circle, so then how can we have 365 days a year, not 360? It's like all of that didn't even register for people, because look, even at 500 BC, the solar calendar that was being used was probably derived off of the Egyptian calendar, and that was 365 days a year. It might have been based off of a lunar calendar. But look, the Julian calendar was formed in 46 BC. He changed it from 365 to 365.25 days per year. And so since then, up until, heck, Gregorian calendar, which is formed 1582. So right now, 365.2425 days per year has been set in stone. And during that time, Galileo's time, the Catholic Church was very powerful, and it taught that the Earth was the center of the universe. Galileo was told not to write or say that the Earth orbited the sun. He could not be silent. In 1632, Galileo published a book said that the Earth orbited the sun. I thought there's more to why the Gregorian calendar. Okay, so this one doesn't have it, but basically the Gregorian calendar was formed just so everything could match up with the spring equinox, or not the spring equinox. Yeah, spring equinox coincided with Easter, I think. You could look into it. It's been a while for me. So look, this is today, 2018. Today is actually 2019. Oh, you guys can't see it. Let me hide myself. You guys don't need to see me, see? So that's what I was saying. And you could go and look into it. So I'm just thinking, the ones, here's where it gets me. All right. So the ones who the Greeks, I don't know what the Greeks, why don't we look it up? Greeks, ancient Greeks, actually. Greeks calendar. Here we go. Ancient Greek calendars. Okay, second results. Wow, there's a lot of different regions. But let's go with, well, they don't have Alexandria. They don't really tell you anything. What bogusness is this? Ancient Greek calendar. Well. Oh, shoot. Thank you for a whole bunch of bullshit. Alright, let's look at the images. Oh, how about... days per year. Let's just change it up. Oh, so they kind of mixed, I guess. Olympiad calendar only for historical purposes. So the term Athenian calendar, also called the Attic calendar, has become somewhat of a misnomer since ancient Athenians never really used just one method to reckon the passage of time. Athenians never, alright, especially from 3rd century BC forward, consoling one of 5 separate calendars: Olympiad, seasonal, civil, consoliere, and finally Metonic. Okay, so here, a solar astronomical year, however, counts 365.24 days. Athenians understood from a very early time, especially with the advent of farming, that a lunar year fell 11 days short of a solar year. So they were definitely going, they knew about the solar astronomical year. One synodic month in 3 years and drift through the seasons in 33-year cycles. But they were, looks like they were going mostly by the lunar year. This is more that I even have to look into, because I'm looking now. I have to look into the ancient Greek side, not just because the ancient Greeks. What I want to know is what calendars were they using, and if they did know about the solar calendar being 365 days a year, or maybe even the lunar calendar 354 days per year. How come they never thought of it? Well, has, you know, a full circle is 360 degrees. So what's up with that? I mean, how could they not observe that, hey, if we're using these calendars and it's not full 360, then obviously we're not in a full circular orbit if we're thinking that there is an orbit. So all of them are thinking, hey, it's 365 or 354, and where do we come up to make it 360? Because if it has to be a ball, it has to be a globe. I mean, and even everyone here, all the great big scientists of the 1600s to the 1800s, they didn't think about the entire idea that, hey, how come we keep using these calendars that aren't 360 degrees until, like, I guess Johannes Kepler came to be, and Catholic Church was like, okay, it's elliptical. Okay, so another thing, I don't know where I was going with this. Let me see. That's why I don't like to preview, because I haven't formulated my thoughts on it too well. But let's look at this again. See, this is a two-dimensional shape of the moon, right? It's printed out. It's a picture. Now this thing over here, right? A lot of people also say, hey, we know the shape of the Earth because the moon is also round. It's a ball. It's like, wait, how do you know it's a ball? This is an observation, right? Could it be a flat disc? And it's like, you could say, I know what globe earthers are going to say. No, we know it's not a flat disc because we have pictures of the dark side of the moon. We've got astronauts that have been back there. We got all this evidence. Okay, so the gatekeepers are your evidence. But just looking at this as an observation, can this be a flat disc? I'll forget about my cut there. Yeah, you have to be honest again. You don't have to be the smartest guy in the room. You could be the dumbest like me. But if you're being honest, this could be a flat disc. Not a round ball. We don't know what's on the dark side of the moon from here. So if you're asserting that, well, most likely it's going to look like a ball, a round ball. Therefore, the Earth is a round ball. So if you make that same claim without any proof, just based on an idea, just an assertion that just based off of observation, well, do you see the moon rotate? Do you see it spin? Do you see it spin on an axis at anywhere? I mean, great thing about current technology and internet, we could talk with everybody from across the world. Everyone takes pictures, they upload it. Do we ever see the Earth rotate? Well, you're not, because they already have an explanation. NASA already has an explanation. But based, again, gatekeepers, based on observation, be honest. If you're saying that Earth is a globe because the moon is a globe, well, is the Earth rotating on an axis, spinning on an axis? If we don't observe the moon doing the same thing, or actually, if we observe that the moon isn't tilted in an axis and rotating, then why are we assuming that Earth is also doing the same thing? We should be, if you're thinking that, hey, this is a round ball, therefore Earth is a round ball, well, you can't say that Earth is also tilted and rotating because the moon does not tilt and it doesn't rotate. Simple as that. You're going to be contradicting yourself if you take one or the other's position. And again, it's on observation. You don't need NASA to help you observe what this is. All you have to do is go outside and look at the moon. Do you see it tilted from your position or move from any actual position? When you look at it day in, day out, same place, different place, it doesn't matter. Do you see it rotate? No, it does not rotate. So why do you assume that the Earth is? Just based on observation. But then again, you're going to look up and go, hey, why doesn't the moon rotate? You're going to get answers from the mainstream corporate and what do you call it? The official narrative that's pushing this. So again, I'm not here to prove one way or another that because this is flat. This is a flat moon that doesn't rotate, that doesn't tilt either, like daily or whatever, based on the orbit of the Earth around the sun. Same thing with the moon's orbit around the tilted Earth. Just because I'm not stating the same thing that globe Earth modelers are saying, because I see this and stating that it's a globe, that Earth is a globe, in the same measure where they are saying that the Earth is tilted and rotating. Well, how come the moon isn't tilted and rotating? If we're to observe that what's up in what we're saying with the moon, we're applying that, well, most likely the Earth is the same way. So you won't see me declare that the Earth is flat because the moon is flat. I'm declaring that the Earth is not moving or on axis or rotating because the moon doesn't have an axis or a tilt and not rotating. I'm not here to, as far as flat earthers, I think may be disappointed that I'm not trying to prove flat earth, or I'm not trying to give out models of the flat earth. I'm just looking into the globe earth, just like I want everyone else to look into the globe earth. Is this proof? Can I do observations where it could be something else? Yeah, I can. And so can you. If I can make an observation, you can make an observation. The problem with the scientific method, which I don't really actually see the scientific method being stated as proof of the Earth globe, not by any mainstream. Maybe I'm not looking it up exactly as the Google search engines it should be looked up. I mean, you could do it. I'm just looking into, okay, they're debunking flat Earth. What's there to debunk, really? That it can only be one thing through observation or experiments? Well, let's see it. And we look at it and we go, okay, let's focus on that. Let me do the same thing. Because those are the things that you can actually look up. Okay? The proofs, whatever that they want to give out that any ordinary person can do, you can do it. You can, instead of sitting there, wherever you are at, and just watching me talk or watching whoever else talk, let's go out and look at the 3 proofs. If it's historical, look at the history behind it. It's pretty simple. It's out there. And it's like, is it proof? And how did they measure it? Oh, they had to make, Eratosthenes had to make 5 important assumptions. And this translates into gravity as well, because you can't calculate gravity without the radius of the Earth. Because the radius of the Earth needs the universal gravitational constant in order to calculate the mass of the Earth and to find out the actual force of gravity. So you need the radius of the Earth right here, that's in square, in order to find out the mass of the Earth right here. Mass of the Earth. Okay, you need that big G. Now that big G was measured by Henry Cavendish, which is here. So if you know this and you know this, and this is coming from an assumption, you come up with an assumption of what the mass of the Earth is, but everyone regards it as a fact, as scientific proof, as evidence based off of assumptions. So you're going to get this, which is the force of gravity, which is 9.8 meters per second squared. Once you know the mass of the Earth, okay, so this right here tells you everything you need about gravity. Now this is based off of the assumption that we're still holding up to the Newtonian model, where gravity is a force. But once you get to Einstein, gravity is not a force. Go and look that up. So this can be thrown out. It's just a big circle jerk. It's horrible. If you're confused, that's what it's meant to be. It's meant to confuse you. And they're going to say, oh, you're confused? Well, then you don't understand it. Here's these scientists. And then they'll go on and drone and talk about these equations, this, and who discovered this, who calculated that, and all this other stuff. But all you have to do is make it simple. Oh, and I was listening to Nathan Oakley, okay, who came up with that quote. Quote, simplest, Occam's razor, sorry. I'm not even sure if I said that. Okay. Logic principle attributed to medieval philosopher William of Ockham, or Ockham. The principle states, and this is used scientifically a lot. It was used by even the person who wrote Contact, Carl Sagan. It's used in the book and in the movie. Occam's razor. Logical principle attributed to medieval philosopher William of Ockham. The principle states that one should not make more assumptions than the minimum needed. This principle is often called the principle of parsimony. It underlies all scientific modeling and theory building. So, one should not make more assumptions than the minimum needed. So what is the minimum for calculating the radius of the Earth? 5 assumptions. Is that the minimum needed? Is that the minimum needed? What's the minimum? Is 5 the minimum? Is the minimum 1? Is the minimum 2? I mean, we need to limit the assumptions needed, right? I wish he kind of, I mean, so if there was an assumption of, someone did a calculation of the size of the Earth and the assumptions was limited to 4, would that supersede Eratosthenes' measurement of the radius of the Earth? Would that be proof? It wouldn't be proof. But it's something that a lot of scientists, a lot of globe earthers, even flat earthers, this is what a lot of people attribute when you're talking about science. You're talking about logic and reasoning and all this stuff. That a lot of people will bring up Occam's razor. The thing is, people get that quote wrong. The principle is based on that one should not make more assumptions than the minimum needed. And by why we're getting it wrong is Contact, quote, Occam's razor. In the movie, she says, and she gets this wrong, yes, it's a scientific principle that all things being equal, the simplest answer is usually the right one. It's not exactly, of course, they say roughly. But a lot of people, they're going to be based off of the Occam's razor principle. And you're going to see memes, right? Let's look at the memes of Occam's razor. Like a lot of, like, Occam's razors. So let's look at, that one's good. I like it. Just a cartoon. Here's another one. I don't know how these guys made it to these ones made it to the top. But here's another one. 84 best Occam's razor images. The simplest explanation is usually the correct one. That's not really Occam's razor. That's not his principle. This is it. And here's the one. All things being equal, the simplest solution tends to be the best one. No, that wasn't it. It's here. The explanation requiring the fewest assumptions is most likely to be correct. The key word is assumptions, the fewest assumptions. Because the more assumptions there is, the more possibilities. And the more assertions that you're assuming something is occurring or something is. You can't do that because the more assumptions you have, the more things that you're making up on the go. It's like when someone's lying, they keep building up on their lie. So if you have to keep building up on something, it's like, no, just give me the brief. Just give me the most concise, correct. You know, I don't have to assume so many things because the more things I have to assume, the more I have no idea what the hell is going on. That's another topic in itself that I would like to do, but I don't know. There's so many topics I want to talk about. Even this topic, which I wanted to leave at 43 minutes, is an hour 10 now. So, okay. That's that. I'm going to move on to the next one. I hope you enjoyed it. So, again, if you're watching, my title, Curved Shadows on the Moon, is a proof of the shape of the Earth? No, it's not. There's at least two possibilities. Having two possibilities is not proof. It's like if you're a juror or a judge and you got two possibilities, a person murdered that person or a person didn't murder that someone. Are you going to choose one over the other without enough evidence or proof for that matter? Like, well, if this person I say is guilty and, you know, I've got to pick one or the other, well, that person's going to prison for so and so many years or a lifetime, where they're going to just have the death penalty. Like, really? It's like, you don't know one way or the other, but you're just going to pick one and it's going to affect that person's life. It's like, how is that fair? How is that justice? How is that finding out the truth? So if you don't have enough evidence to prove without a reasonable doubt that it is one over the other, then don't make that decision. Leave it at the courtroom floor. It's like, everybody go home. Innocent until proven guilty. It wasn't proven, so not guilty. That's how we do justice. That's how we should do science. That's why the scientific method is there, to help us do the correct science. I don't know why I have to be the one keep telling people this. I know there are a lot of others that do. So, and credit goes to people who are on Nathan Oakley's panel, who just repeat day in, day out scientific method, asking the globe earth people, hey, what's the scientific proof? And maybe not even scientific proof. Give us the proof. And then all we have to do is state, well, if it's a proof, then how come this observation, it could be something else? Based off of observation, not scientific method, not scientific proof, scientific evidence. Everyone, if you're going for certain proofs that even NASA states, well, you're getting into territory where the scientific method wasn't even developed at that time, if you're talking about the ancient Greeks. So it's just going to be based off of observation and measurement and deduction, logical deduction. Okay, it's going to be based off of that. So based off of observation is not going to prove anything. Even the people who are going out and taking photos and videos, while it's good, it's not going to prove anything. The thing about what all the flat earthers need to do, they don't need to prove flat earth. All you have to do is go out and support and test and verify the observations and tests and demonstrations that the globe earth is doing. Let's go ahead and repeat it. And then also maybe vary an independent variable and say, hey, so this observation that you have, all well and good, but you know what? We're going to replace this independent variable with this one. Now, is the earth still a globe? Is it? Or let's look at this. Is the actual trustworthy someone who's never lied, someone who's never faked anything as far as the shape of the earth, unless it's satirical? Like I did a satire with Brie Larson, right? I do a lot of satires. Chet Mangold is one of them, where I use a green screen. It looks like I'm a professional newscaster or whatever. But still, look, when we're talking about this, look, if I fake anything, and a lot of agents go and troll and go, oh, you faked the results of this video. He's like, all right, prove it to me. Go and look at the timestamps here. If you don't see these same timestamps, well, okay, I guess you've proven to me that I faked it. Although I'm proving to you I didn't. By all you have to do is look at the timestamp here. You know, this is why I'm a flat earther, because of Stephen Hawking and 3 birds. Oops, you guys can't see it. Like, if you think this is fake and edited by me, I'm sorry to tell you, I didn't fake it or edit it. All I did was take timestamps of the video in question, paused it just for this video, just so you can see, hey, this exists on that same video. I didn't have to do anything. Here, I admit I edited everything so you can see exactly what I did. And of course, when I tell you I edited something, I'll show you how I edited it. All right, this time in sync. How about snapshot by snapshot? There's one. Where is it? All right. And okay, let's slow it down to 0.1 speed because I want to show it to you in slow motion. Of course, 0.1 speed, and I tell it to you here. It's not exactly 0.1 speed for one of them because they're off. And that's why I had to do a snapshot by snapshot, because when PBS, the show Genius by Stephen Hawking, when they edited the footage of the helicopter, they were using the same everything else with the 3 birds that are flying across. They edited the video and they adjusted the speed of the video. I don't know exactly what that speed is. If I did, I wouldn't have to take the snapshot by snapshot. I could adjust it to 0.1 and 0.08623, whatever it is. But it's hard. I tried. I spent probably an hour trying to seek it that exact way, but I couldn't. And that's why you'll see it being slightly off. Even in this, see? That's why I had to take the snapshot by snapshot. And you can see snapshot by snapshot, frame by frame, where it matches the syncing up the formation of 3 birds flying across the water. While you see that this has no helicopter, this one, because it went down, or they say it went down, this one's going up. Okay, everything is presented exactly how I want to present it. So you can do the same thing. Just go view the video, put it in some editor, and slow it down so you can see it, and take snapshot by snapshot. You'll come up with the same result. Many people have done this too. And that's it. It's like, alright. Globe Earth model, they have to lie. I've already done my research on NASA. They're lying. So where does that leave me? Well, that the Earth is not a globe. But the Earth is not a globe, what could it be? I don't know. That's what a lot of people are wondering. Like, if Earth is not a globe, and depictions of ancient civilizations and the ancient civilizations all have something like this, where the surface is a flat plane with mountains, hills, whatever, but it's not a spinning globe like the continents, and like this, the blue marble everyone's familiar with, that it's more like this. And I'm thinking, well, let's look into that. And all these depictions show that there's something in the center of the world, and a lot of the biblical stories, mythologies, whatever, the center of the earth, they always talk about something being there. But when you look at the globe Earth model, center of the earth would be the magnetic North Pole. And you look at that in the mainstream sources, what do they tell you? They tell you it's just water or ice, and it keeps moving south. There's nothing there. And they've never been there before. You don't see any videos or pictures, and they tell you, oh, that we've been to the geographic North Pole, but the magnetic North Pole, you don't see anything. We got more pictures of the globe Earth. We got more pictures of astronauts on the moon than we've got of the magnetic North Pole. Heck, take a picture right over, or a video of the magnetic North Pole. It's like throw some metal filings or something out there, see what happens. Is it gonna be like hovering or collecting all that? It's like, I know that you guys are saying that the magnetic pole is very, very weak, but all compasses point to it. All compasses point north. You say it's so weak. Oh, but the magnetism between the North and South Pole, it protects us from solar flares, etc., etc. So it's that strong to protect us from this huge fiery sun that you have that can burn us to death, cause droughts, and destroy satellites and all this other stuff. And all of that stuff, but it's too weak where, you know, if you even fly above it, it's not going to do anything. I mean, if you can fly above it with a magnetic, or with a metallic plane or a helicopter. Maybe that's why there's not many videos of it. Will it even affect the camera, video camera, whatever it is that you're filming with? Maybe that's why you don't have any pictures of the magnetic North Pole. So a lot of it is, well, they won't let you go. They're not going to let you go and find out and show everybody. For whether it's the Antarctic or the magnetic North Pole. But aside from that, they're going to just say, hey, there's nothing there. We've already explored it. Look, there's pictures, there's nothing there. There's little diagrams and fake pictures and whatever. There's nothing there. Oh, look, just a bunch of clouds. It's going to be clouds and snow and water. Yeah, there's just so many wildlife that even live in the tundra. 3 animals that migrate. Let's see. Arctic migrations. Here's Conservancy, oceanconservancy.org, one of the biggest Arctic migrations you've never heard of. And just look that up. You're gonna find I love nature, I love animals. You're gonna see so many migrations to the Arctic region. No one makes those journeys or migrations towards the Antarctic. Like, why would any animal, much less multitudes of animals, birds, marine mammals, fish, go to the Arctic region if it's supposedly very, very cold, a lot of ice, no land, or hardly any land? It's like, why would they go there? Huh? I mean, there's nothing there. Is it because of attraction to the magnetic pole? Why would they be attracted to the magnetic pole? I mean, you've got Florida. This magnetic. You got the Mag Lab in Florida, the largest and highest powered magnet lab in the world. Why aren't all the animals migrating there if it's because of the magnetism of the North Pole? They say this is 100 times. How much more powerful is it than the magnetic North Pole? Magnetic laboratory. Let's see. This one has North Pole in it, so let's look up North Pole. Let's see. Okay. This time I hope I find it. I found it earlier in another video. Why do I put man? Oh. Let's see. Strongest egg in the world. Okay, so here, Uber Gizmo, July 20th, 2011. It's the first result, really, if you're not going to buy one of these magnets. World's strongest magnet is 500,000 times stronger than Earth's magnetic field, and that was 8 years ago. So who knows how much stronger they've got it now. Do all these animals migrate to Florida, where this is? Florida State University, because the attraction to the magnet? Whenever they turn this on, I don't know when they turn this on, but do our compasses start pointing to Florida for north as opposed to the north, the North Pole? I would say no. I would say, hey, turn this thing on, leave it on for a day, and everyone get your compasses out. Where does it point to? I'll bet you. Unless you're like actually in Florida. But if you're like me in Nebraska and I have a compass, and you're in, say, in Seattle, Washington, and you have a compass, or you're in Mexico and you have a compass, where's it going to point to? I'll bet you it points to the North Pole. It points north to the North Pole. And how do you do it? Well, why don't you go outside, look at Polaris. Can you see Polaris? Good. Let's go ahead and point it to that direction. That's north. And let's look at our compasses. Oh, it's pointing north. And let's look at all right, hey, Florida State University, is your thing on? I thought you said it was 500,000 times stronger than Earth's magnetic field. How come our compasses aren't pointing to your laboratory? These are things that no one even questions or thinks about or asks, yet I have to be the one doing it. I mean, there's so many people who probably thought of it and asked that same question. And I always think it's just so funny how they keep stating that the Earth's magnetic field is so weak, yet it does all these incredible things, and that we can make things much more magnetic and powerful. Yet when we actually make observations of these tools that are supposed to measure, like a compass, the directions of the strongest magnetic readings, it's not pointing to all these strong magnets whenever they're turned on. It's like, if I had a compass set 365 days a year, and I just look at it and say, hey, when is it? I just leave it. It's like, if it moves from north to any other direction, I'll timestamp it and go, hey, this moved to a different direction other than the North Pole. What happened? And maybe I'll see on the news is like, hey, if you found a discrepancy in your compass and it pointed this and so direction, it's because we have a laboratory that has a really, really, really strong magnetic force, and that's why. And I'd be like, okay, I guess Earth's magnetic field is that weak. If I find it's something just nearby, someone created a huge magnetic field in like a nearby, I don't even know if, I think there is a university, or at least a college, or maybe community college in Columbus, I don't know, maybe that's what caused it. But still, if it's supposedly 500 times stronger than the Earth's magnetic field, you'd have to go 500 times the distance of where the North Pole is, which is stronger supposedly than the South Pole. Well, I mean, how far do you have to go? Or, you know, it's just crazy. Crazy talk. Oh, I got a splinter in my finger. It's not infected, so that's good. Okay, so that's it. Wow. Other people must be doing something exciting or watching something exciting. What am I missing out on? Okay, that's it for this one. I'm going to do another one. I'm not going to do 3. All right, I'll see you guys in a bit. Or you guys will see me if you guys are watching.